Last year, brands spent $24 billion on influencer marketing and UGC ad content. That's hiring creators, shipping out products, and waiting weeks just to get a few videos back. Now, imagine generating all of that instantly. Upload a single image of your product, and this AI workflow turns it into realistic influencer-style videos ready for Instagram, TikTok, and Facebook in seconds. No cameras, no actors, no shipping products, just dozens of scroll-stopping ads on demand. In this video, I'll show you how we built it using OpenAI's new Sora 2 video generation model combined with n8n, and how you can use it to create or even sell UGC-style ad campaigns completely on autopilot. All right, jumping into the UGC video generator built here in n8n using OpenAI's new Sora 2 video model. This section will be a quick high-level demo, and then we'll jump into the full node-by-node build with Lucas in the next section. So to kick off this workflow, we simply need to upload our product image and our product name. We're going to pretend we are Ridge Wallet, and here is the product that we are uploading. So we'll upload that here. And then the product name we need to include so that the UGC model knows what to say in the video. We'll submit, and that will kick off this workflow. So first there'll be some data cleanup, and then we'll jump into the OpenAI Vision API that will allow the system to analyze the image and ultimately generate a relevant model for this image. So the prompt here is the core identity for the model. This is essentially just creating a description for the system to build an AI generated model that will then get passed and created in the video that we feed to the Sora 2 API. All right, then using the product image and the model, this node will be in charge of meta prompting the scripts for the UGC video. Once we've generated the prompts for the video scene, we'll first generate a frame for the product. And here we'll use Google's Nano Banana to actually create a frame that matches up with what the Sora API needs. Because in this example, our product photo is a square, and it actually needs to be in vertical video format, so the video generates vertically. And so this section will actually generate the frame, as you can see here, with Nano Banana in the dimensions that the Sora API needs to generate a vertical video. So then it's going to take all of that input and start generating the actual videos from the meta prompting, the model, and the image that we uploaded. And here we have the output that it generated.
Yeah, so about the wallet. Honestly, this is the Ridge wallet, and it just disappears in your pocket. I can fit what I need, but it's like, I don't know, it's just efficient.
So that's a good example.
Okay, so this just arrived. This is the Ridge wallet. And the construction is just so solid. There's literally zero wasted space. I mean, look how thin that is. Yeah, this is thin.
We also ran the same workflow for a beauty product, a shampoo product.
Okay, for my wavy hair, a few people asked, and honestly, I've just been using this, the Function of Beauty shampoo. It's like not heavy at all, which is my main thing. So yeah.
So pretty freaking spectacular output. If you want the prompts and this whole template for free, you can snag it in our AI Automation Mastery School community. It's completely free to join. You'll just navigate to the n8n templates for whichever automation you want to download. And then here you can download the JSON and import that into your n8n instance. So with that high-level demo, now we're going to kick things off to Lucas, who will showcase the full node-by-node build and break everything down. Okay, before jumping into that though, if you're an e-commerce brand that wants our team of AI video generation specialists to generate killer AI video ad creative for your company, reach out to us by filling out the short form that's linked in this video description. You can literally save thousands of dollars and drive up your return on ad spend dramatically because you'll be feeding way more ad creative into Facebook systems. So fill out the form below and we'll be in touch. And now let's jump over to the complete build with Lucas.
I want to kick things off here going through a detailed system overview for our UGC ad generator powered by Sora 2. This one's going to be a little bit more complex compared to some of the other generators we've built in the past, especially the Nano Banana ad generator, just because video is involved, there's more inputs, and it's a brand new model. So I want to take you guys through this step by step. The first thing that's going to happen on this automation, just like what we covered in the demo, is going to be the upload of a simple product photo of whatever e-commerce product we're trying to promote. So we got a Ridge wallet here that is a couple of different angles, which is a perfect high quality photo to kick this system off. After that's done and processed by n8n, we're going to go forward with using the OpenAI Vision API to go ahead and analyze that image we just uploaded and generate a description of an influencer who's going to be the ideal persona to go ahead and promote our product to their audience. And so we're kind of analyzing this image and inventing an influencer who the AI thinks is going to be a perfect match to promote our product we just uploaded. After that's done, we're going to then move on to another AI call using Gemini 2.5 Pro to go ahead and write multiple UGC video scripts for us that takes into account our product photo we just uploaded, as well as that persona we just generated. So we're going to take those inputs, pass that off to Gemini 2.5 Pro here, and go ahead and write out some video scripts for our invented UGC creator to go ahead and speak for us. After that gets done, with our scripts in hand, we're going to be using Nano Banana to go ahead and generate the very first frame of the video that includes a picture of our product. The reason for this is due to the way that OpenAI has set up their Sora 2 API. They set it up in a way that if you want to attach a reference image, it's going to be the first frame of any video you're creating. And so on the videos we generate, we're going to see here that we have a product photo that's flashed in the very first frame of our video, and then it's going to transition into the rest of the video with our invented UGC creator and that product in hand. By providing this reference product image, we're just going to be able to guarantee that the dimensions, the sizing, the colors, the shape provided into the system is going to match what is happening inside the video. This may change in the future depending on how OpenAI structures their Sora 2 API, but this is just a little bit of a hack I found in order to get a consistent product to actually appear like it does in reality in the videos we generate. So we're going to generate the first frame of the video using Nano Banana. So we're going to take our product photo, compare it to another template image to make sure it's dimensioned properly, and then we're going to pass that first frame and our full script we written out into the Sora 2 API to go ahead and generate our final video. And since we're telling our system to generate multiple scripts for whatever product we upload, we're just going to loop over all of these and generate a video one after another, and finally upload that here into Google Drive. Before we switch over to n8n and go through this workflow node by node, I also want to give you guys a brief overview of the pricing involved with the Sora 2 API and some of the limitations that are currently in place at the time of filming this. Starting with the pricing, there's actually two different models that OpenAI released with the announcement of Sora 2, and that's going to be the Sora 2 model and the Sora 2 Pro model, each priced differently. Starting with Sora 2, the standard version of this video generator, all API calls and videos you generate are going to be priced at 10 cents a second. So if you're making a 10-second video, that's going to be $1 a video. In this case, we're making 12-second videos, which is the maximum length of video supported at the time of filming this. And so we're going to be looking at $1.20 per video we generate. So if you're working through any bulk creation workflows, just keep that in mind. Same thing goes for the Sora 2 Pro API. The main difference here is it's a bit higher quality output. And so OpenAI recommends using Sora 2 for short form video you're trying to generate. And then if you're trying to create something that's a bit more theatrical or stitch together a short film, OpenAI recommends using the Sora 2 Pro model, which is the bulkier, more expensive model. This is going to be priced at 30 cents a video, so 3 times the cost. And so if you were to swap out the model for this automation we're building, you're going to be looking at $3.60 for every UGC video that you generate. This much better pricing than VO3 is right now, but over time, I imagine these costs are going to go down as compute capabilities rise. Something to follow here and something to keep in mind as you're building with Sora 2. The next thing I want to cover here are going to be some of the limitations set in place by OpenAI for working with Sora 2. That's going to cover things like using human faces, real people, copyrighted characters, and copyrighted music. Each of these points are actually disallowed for the moment. And so one use case somebody may consider is trying to create an AI model and then pass that off to the Sora 2 API. You're actually going to get a content rejected error if you do that right now, because no human faces can be accepted, even if that human face doesn't exist and is generated by AI. So that's something I tried first and unfortunately didn't work out. So hopefully we'll see that changed as time goes on. This is more of a safety precaution OpenAI has in place to launch this video model. Another part, just building off of this, real people can't be generated. So if you say, go ahead and generate a video of the president, it's going to get rejected and denied since it's a real public figure. Same thing goes for copyrighted characters. Can't generate videos with Mickey Mouse or SpongeBob. Same goes with copyrighted music too. Hopefully that's some helpful context here and it helps you avoid going down any frustrating paths with your videos you try and create. So with all of that in mind, let's start going through these bullets one by one and do the node by node walkthrough of our n8n automation. The first thing we got to cover here is going to be the trigger and entry point into our system, and that's going to be handling the upload of the product photo we took from before and need to get processed. So we got our Ridge wallet here. Let's go ahead and switch over to n8n, and we're going to see that we have this form trigger set up right here. There's going to be two different form elements that a user is going to fill out when they want to kick off this process to generate UGC ads. We are going to have a required field here, which is going to be a file upload, which is going to be our product photo picture. So I have this shampoo here, which was a test run I just did. So let's actually refresh and start this from scratch. So I'll execute the workflow. We'll upload our product here, which is going to be Ridge Wallet. And then we also have this other field here for our product name. So I'll just type Ridge Wallet and kick things off. If I pull up the form trigger once again, and scroll down to the bottom here, we can then see that other field we have as input, which is going to be a simple text element input, where we define this as the product name. So, the product or brand name we're trying to promote here in the UGC video. And then we just mark this as required, just like what we did with our file upload. This is going to be helpful context. We pass through the rest of the automation, and so we know how to build this UGC script. The next node we have here is going to be something that is required to work with a couple of the APIs, including Gemini 2.5 Pro and Nano Banana. And so whenever I'm working with a file that I know I need to use later, I like to go ahead and just convert this into a base 64 string to give me more flexibility when working with these APIs. And so if I pull this up, this is just going to be on the left-hand side here. We have our binary product photo as input. So once again, we have this Ridge wallet here. We're going to be using this move file to base 64 string operation, and that is going to convert this image into this text here on the right hand side, which just contains all of the data required to build this image. And so later on, we're going to pass it off to Gemini 2.5. We're going to pass it off to Nano Banana, but this is just something I like to do when working with images that I know need to get sent off to AI models. I'm then going to use another node here that converts that base 64 string back to a file, just because the next node is going to be working with a binary file. Unfortunately, with n8n, you can't look back to a past node and reference the binary data coming from it. You may find yourself in circumstances like this where you have to convert to and from a base 64 encoded string. And so this is going to be a convert to file node we have right here, and the operation is going to be move base 64 string to file. And so we get that exact same file back from our base 64 encoded data back to a binary file. That is going to get used as input here for our next node, which is going to be using OpenAI's Vision API to go ahead and analyze the product and generate an ideal persona who's going to promote our product in hand. If I open this up, we can then scroll down to the bottom here because we require an input type as a binary file. And so we need to rely on this data file coming here from the left-hand side as input into this in order to successfully pass this image off to OpenAI's Vision API. So if I scroll up, we can see then we have our credentials set up here for connecting to OpenAI's API. We're going to be using the built-in image resource here, and we're going to use the analyze image operation. And we can take in images and answer questions about them. So this is perfect for our use case where we want an images input and a text description of the ideal persona to go ahead and promote this as output. And so that's the exact approach we've taken in our prompt here. I'll pull this up and go through a couple of these steps, but I'm not going to go into reading this whole thing. If you want access to this full prompt, be sure to join our school community by clicking that first link in the description of the YouTube video. Open up the post that matches the title of this video, and then you're going to be able to download this full n8n template and this entire prompt that you see here. So let's look through the role and goal setup we have here and touch on a few key points of the prompt just to give you guys a little bit of a better understanding of how we approach this. So you are an expert casting director and consumer psychologist. That's the role we're setting up. Your entire focus is on understanding people. Your sole task is to analyze the product in the provided image and generate a single highly detailed profile of the ideal person to promote it in a user-generated content, aka UGC ad. The final output must only be a description of this person. Do not create an ad script, ad concept, or hooks. Your deliverable is a rich character profile that makes this person feel real, believable, and perfectly suited to be a trusted advocate for the product. So once again, we're analyzing the product and we're going to lean on AI to take in those details from the product image and invent this person who's going to be the best advocate for us. As we scroll forward, we're going to get the product name that was passed in from our form trigger. And then we just get into some extra details here for what's like the core output, or what's the templated output we want it to look like for our customer profile. So we break down name, age, gender, location, physical appearance, personality, and even get into some of their lifestyle, really giving an entire profile here that's later going to be used to get passed into the video script we're writing, just to really encapsulate what this person's about. So we have that generated here, and on the next node, we're just going to use a simple set field here to pull out the result of that OpenAI image analysis. So we can see here for our Ridge wallet, we invented this 32-year-old male named Marcus, who is living in a sleek apartment in San Francisco, and he's a UI UX designer at a mid-sized fintech startup. So pretty detailed here. We then get into the physical appearance and personality and how they communicate. So kind of crazy where we're able to go from a simple product photo to this full detailed profile just based off of that image. Let's continue here to the third bullet here, where we're going to make use of Gemini 2.5 Pro to go ahead and write multiple video scripts for us for our UGC ads. So I'm going to pull up n8n and get into this next row. So the first thing I have here is going to be the set field node, where I detail a simple text field that is going to be the prompt responsible for generating all of these UGC ad scripts. This is going to be something that is pretty generic and is going to be able to handle a wide variety of different product images we upload. Whether it's something, more male focused like the Ridge wallet, or something that's more of an aesthetic product like shampoo or lip gloss or something else. This is going to be able to analyze that product, think through the ideal customer persona that we wrote from before, and go ahead and generate a couple of different UGC creator scripts that have that product front and center. So let's go through the intro part to this prompt so you can get a better idea of how we approach this and how it can be tweaked for some of the different use cases you may be facing on your business or your client's business. Let's start off with the master prompt we defined, which is going to be writing a script for this 12-second UGC video. You are an expert at creating authentic UGC video scripts that look like someone just grabbed their iPhone and hit record, shaky hands, natural, zero movement with zero production value. No text overlays, no polish, just real. Your goal is to create exactly 12-second video scripts with frame-by-frame detail that feel like genuine content that somebody would really post, not manufactured ads. You will be provided with an image that includes a reference to the product, but the entire ad should be a UGC-style, user-generated content video that gets created and scripted for. The first frame is going to be just the product, but you will need to change away and then go into the rest of the video. Then we further break down the aesthetic and other visual details we want this video to be structured as. We then get into some anti-prompting cases where we detail the scenarios we want to avoid. So perfect framing, we want to exclude. This should feel natural, like somebody, again, is just grabbing their phone. And we detail some other stuff like tripod, stable surfaces, graphics on screen, all things like that would make the video feel overly produced. Setting up these cases does help steer the prompt to be more accurate with the video we're generating. And then we have this 12-second structure that has a set of loose guidelines that we want our scripts to follow. This is a bit loosely structured here for just how we wanted to build a prompt that could handle really any type of photo that got uploaded. But if you're niching down and building something more specific, say for a skincare product, you can change this as you need to make it more focused on what type of UGC ads are really performing well in your industry. And so if you need to change this up, this is going to be the spot to change how we write our video scripts. Going forward, we then get into our inputs here where we're defining our creator profile that was generated by AI from before. We have our product name inserted from our form trigger input. And then we're defining our output as we want AI to write us 3 natural sounding scripts. Going forward, we then break down a format where we have the script number as a header. We have other details here for what type of energy level we want this script to cover. And then we actually are breaking down timestamp by timestamp what lines are actually going to be said and what camera positions are changing throughout the full video. We're going to let AI handle the writing of all of that, but we're just giving a template here for what the final output needs to look like. So for every video script we're generating, we can read through it exactly the same way and get a good idea of what that video is going to look like. So that's a high-level overview of this master prompt here that is going to take in that product photo, take in our ideal creator persona, and go ahead and generate multiple UGC video scripts. After we have that prompt written, it's then time to take that prompt, take our product image, and pass it off to the Google Gemini's API. We're going to be making use of Gemini 2.5 Pro to go ahead and generate this, and are setting this request up by using simple HTTP request. The reason I'm doing this is because I want to actually pass in that raw base64 encoded string of our product photo created from before, just to give the model more context on how it can effectively write an ad for us. If we just passed in the text from before with the title of a product, it's not going to have a good idea on how it can write an effective ad. And so we're letting the model actually see the product photo we uploaded into the form this way, so we can get an even better script as output. Highly recommend you do this. I think if you take out that image upload part, how we have defined here in the inline data, you're going to see worse results. So let's go through this HTTP request so you can see how we set this up. This is going to be a post request to this URL we have defined here, which is generativelanguage.googleapis.com. We're using this path here to set up that we want to use an AI model, and then we're specifying we want to use Gemini 2.5 Pro. For our credentials, we have a generic credential type set up that is going to be making use of header auth for this Google Gemini credential I've created from before. I won't go through the setup steps, but if you go to the Google AI Studio, so I'll just pull that up, click on Get an API Key. You're going to be able to create a new API key here, and then click on API Quick Start to go through all the setups you need to go ahead and authenticate your request to Google Gemini. And so just grab this header here for the Google API key, paste in your Google API key here, and make sure you're configuring this as header auth in order to set up this credential. Let me know in the comments if you want to see a full setup guide dedicated just to working with Gemini, but I've covered this in some of my past videos, and so I don't want to take up time here. Let's go forward here, back to our request body to cover how we're passing in both the prompt and this base64 image. So I'm going to toggle on send body. We're going to select JSON here from our body content type. And then I'm going to use the using JSON option here to go ahead and configure our request body. I'll pull this up and we can see that we have this complex object set up here that is going to split up how Google is expecting us to send off both the prompt to the AI model as well as any extra data like images that need to come in too. That's going to all live underneath this contents array and then underneath this parts array. Inside the parts array, we're going to specify a part here, which is going to be text, and that's going to be our text prompt we wrote just from before to generate this UGC style video. So that whole prompt here is getting passed in, and I'm going to use json.stringify just to make sure it's valid JSON getting set on this part. The next part we have here is how we're actually able to pass in these images to Google Gemini. We can't just use a binary file that gets passed off to the Gemini API, and so we're going to be making use of that node I talked about from before, where we go ahead and convert our image into a base64 string. So that's from right after our trigger here at the top. And if we grab the output of that node, we're going to see that we have this really long string here of a bunch of different seemingly random characters and numbers. That's going to be the fully encoded image data for that product photo we uploaded from before, exactly how Google Gemini is expecting to read an image in. So when Gemini is processing this, it's going to take in this base64 string data, convert it back into an image, so it can then analyze that and really build out a strong UGC script for us. That's the gist of it here for working with the Gemini API. After we make that request, we then move on to the next step here, which is going to be going ahead and extracting the 3 prompts. If you recall from before, we're actually asking for 3 separate prompts here, each with a different angle on the UGC video. And so I'm going to be making use of Gemini again to go ahead and extract that into a structured JSON schema that's going to be easier for us to work with inside of n8n. And so if I pull up our parser at the bottom here, this is how you can tell n8n that you want a structured object back and to get extracted from an LLM call. So I have this very simple prompt set up here. So you will be giving text that contains many separate prompts and scripts for a UGC short form video. I want you to extract these into an array of strings where each item extracted is the full prompt or script. The prompts should remain exactly as they were provided. So that's the instructions I'm passing off in my user message here for this AI model call. I'm going to add this divider and pass in the resulting scripts we just got back from our Gemini 2.5 Pro API call. And so we can see we have script 1 here, our analytical first impression of the Ridge wallet. Scrolling down, we should get to script number 2, which is going to be a casual recommendation angle. And then we got script 3 at the bottom. So we want to get those scripts extracted as a structured array so we can easily work with that script in n8n as we go throughout the rest of these nodes. Going back to our parser here, if I pull this up, this is just going to be a simple JSON schema that defines a couple of different properties. We have our properties object here, we have our prompts array, and I'm using prompts and scripts interchangeably here because that's going to be the string that gets passed off to the Sora 2 API. And so this is an array. I describe it as an array where each element is a single distinct prompt string that was extracted from the user's input, matching up to our prompt from before. And then in that array, each item is a single string, so a single prompt statement. I'm saying this is required just to make this more reliable when we're trying to parse out this output and let the AI model retry if it fails at extracting. So that's the main setup here for extracting our prompts. And we can see now that this is run, we have our response output split into this prompts array with script 1, script 2, and script 3, which are going to be the prompts we later pass into the Sora 2 API. I also have autofix format checked below here. That's something I like to do just to make the whole system more reliable. It's going to use AI to try and repair the response it pulls out here if it doesn't adhere to the schema we defined. And so if we mark this as required, have autofix format turned on, this is going to be more reliable as we run this a bunch of different times. After that's done, we're then going to use a simple split node where we look at our output.prompts object here to go ahead and split out this single response into 3 separate items we're going to later be able to process one by one. Let's now move on to these next 2 bullets here, where we're going to go ahead and iterate over each of those scripts that we generated from before and start actually making these videos. The first thing we have to do here is actually pass in our product image into the Sora 2 API by using the first frame option. And there's a little bit of cleanup and extra steps we have to do here in order to work correctly with the Sora 2 API. So I want to jump over to the video generation guide really quick on the OpenAI docs. And so I'm just under this video generation tab, and then underneath this use image references option. And we're going to see this nice guide here on how we can work with the Sora 2 API and actually pass in an image. Since we want our real product featured in this UGC video, this is going to be an essential step for us to follow when making these videos. So you can guide a generation with an input image, which acts as the first frame of your video. This is important to note. This is useful if you need the output video to preserve the look of a brand asset, a character, or a specific environment. Include an image file as the input reference parameter in your post request to the video generation. And this is exactly the case that we want to bring into our video. And so we're going to include our brand asset here, which is going to be the product we uploaded, and make sure that's included. The thing I need to note here, going back to kind of the system overview, is going to be that this is the very first frame of the video we generate. And so it's not perfect yet because we're going to see our wallet flash up on screen, and then it's going to transition into the UGC video. And so maybe Sora is going to be able to figure this out later with changes to their API, but that's one limitation we have to work on right now with some extra editing. We'll probably have to cut out that very first frame of the video and then continue forward with posting our UGC ad. But if you don't follow this input reference image, you're then going to end up in a worse spot because you have to pass in a detailed description of whatever product you're trying to promote. And if the AI can't create it from that description, you're going to get a video that is just hallucinating whatever product you have. And so I found that using this reference image is going to be the best way to go ahead and keep consistent product images, even if you do have to manually edit out that first frame. So now that we have a bit more context here, let's go back to n8n and go through each of these steps for generating that first frame image. What I'm going to do next is actually use Nano Banana to generate this first frame image just to get all of the dimensions in place for the Sora 2 video. One other constraint when working with the Sora 2 API is whatever image we pass in to Sora 2 as this first frame image needs to be the exact same dimensions of the video we're generating. So if we're trying to create a short form video that is say 720 by 1280 pixels, the image we pass in to this generation needs to have those exact same dimensions. In my case, my product photo, I didn't have it in that exact same dimension for the Ridge wallet, and so I am using some extra processing steps here to ensure that it will always be in the correct dimension. So the first thing I do is call into Nano Banana's API because you can use it as an image editor. What I'm going to be doing when working with the Nano Banana API is going to be passing in 3 separate components. I have a text prompt, I have my inline data defined as our product photo we uploaded from the trigger, encoded as a base 64 string. And then the final inline data option I have here at the bottom is a simple dummy file that I created with the dimensions I need. So what I did here was I went to Canva, I made a very simple template with the dimensions I needed. In my case, I'm going to do 576 by 1024 because I need to be at least 1024 or below on my height of the image I'm generating with Nano Banana. Downloaded that, got the base 64 encoded string, and pasted that here into the inline data. So this is not going to be something that's dynamic on this generation request. It's going to be the static constant template photo I have just to make sure my dimensions are set up correctly. Going forward with that a little bit, the text prompt is going to put everything together. So take the design, layout, and style of image A, which is going to be our product photo, exactly as it is, and seamlessly adapt it into the aspect ratio of image B. That's going to be our template here with the appropriate dimensions. Maintain all visual elements, proportions, and composition of image A, and so make sure everything is proportioned correctly from our product photo, but expand, cropped, or extend the background naturally so that the final image perfectly matches the aspect ratio and dimensions of image B. So we're taking our product photo, we're going to expand it, shrink it with the appropriate dimensions so it fits on that new template we made here in Canva that is going to be sized correctly to work with the Nano Banana API. And then going here at the bottom, we're going to just clarify the prompt even further. Do not distort or stretch any elements. Use intelligent background extension, framing, or subtle composition adjustments to preserve the original design integrity while filling out the new canvas file. I know I covered a lot there, but just to reiterate one more time, we have this constant template image here that has the correct dimensions, and we want to make sure we stretch or shrink and really scale our product photo to fit on those dimensions. Because Sora 2's API requires exact dimension matches when we're passing in our very first reference image here into the video we're trying to create. That covers it here for the basic prompting setup and the data we're passing in to the Nano Banana API. And to set up the Nano Banana API, we're going to use this exact same base URL here for working with Google Gemini's API. But instead of using Gemini 2.5 Pro, we're going to be using Gemini 2.5 Flash Image Preview. So swap that out to use the Nano Banana image editor, and you're going to be able to work with this exactly like the Gemini models. I'm using my same credentials here. I'm making a post request, and that full body is getting sent here just like I covered. So we're going to see that this node runs right here. We're going to get our output here as a base 64 encoded PNG image. And so we need to go ahead and grab that result here by filtering down to that first inline data item we're able to get that's included in this parts array coming back from Google's Nano Banana image model. So we got our base 64 string as output right here. And then we're going to go ahead and convert this using that file node here, where we convert to a file from this base 64 JSON data, where we convert that into an image. And we're going to see our appropriately dimensioned product photo here that is going to get passed into the Sora 2 API. And so we take our result here as input on the left-hand side. We're going to use the default here to set it as data on the output. And this is, of course, a binary file. Going forward here, I now have this edit image node that we can find here by searching, edit image, that is going to go ahead and scale this up to the final dimensions we need. If you remember from before, when working with the Nano Banana API, we can't actually generate something that's over 1024 pixels in height. And so we're doing the next smallest size we can generate, and then we're going to go ahead and scale that up to match the final dimensions we need. And so if I pull up this image we just generated and download it, let's grab it under our downloads, look at get info. We are going to go ahead and see here, this is 768 by 1344. It did look like the AI model generated something that was bigger than we were expecting here, and that's not really what we want in this case. So like I mentioned before, we're going to make use of this edit image node to do a final resize just to be 100% certain that our file is the exact dimension we need. Because if we request this and send it off to the Sora 2 API and it's not the correct dimensions, we're going to get an error. So we use the resize operation. We're going to take in data from the left, and we're going to define this as 720 by 1280, which matches the exact dimensions of the video we're going to go ahead and generate in a later node. You can see here we have our image on the left as input, and then on the right hand side we have our other image here as output, just modified a little bit to be the perfect size that's required. Under option, I do have this ignore aspect ratio option set just to force that scale change. I can go ahead then and download this, and we should see that we have our final file options here under get info that now have the 720 by 1280 dimensions. So that's perfect. There were a few steps there to get this in place, but I found this to be the most reliable by combining Nano Banana to smartly scale up and down the image to the appropriate scale we need, and then making use of the final resize image node on the right here to really lock in those dimensions so we don't get any errors as we proceed. All right, we're now ready to move on these final 2 bullets here, where we're going to actually make the API call into the Sora 2 API to generate our final video and then upload it to Google Drive. Let's go over to n8n and walk through that setup. The first node I have here on this bottom row is going to be that API request into the Sora 2 API to start this video generation. So if I pull this up, we can see that this is going to be an HTTP request node, and we're going to be making a post request into this URL. So this is api.openai.com/v1/videos. This is all included here underneath the OpenAI docs. And so if you want to copy this curl command, you can just paste that here into the API request and fill out a lot of these details. Going forward to authentication for this HTTP request, I'm actually going to be making use of a predefined credential type. This is something if you've already connected a ChatGPT, a chat model, or other OpenAI chat model into n8n as a credential, you're actually going to be able to reuse that on the request you're making here under a simple HTTP request. I select predefined credential type, I select OpenAI, or I searched for OpenAI as the credential type, and then I'm going to use the OpenAI credential I already have in place for all of my OpenAI chat models. That's set up perfectly, and you don't need to do anything else here if you already have your credential configured for OpenAI. If you're setting up authentication for the first time with OpenAI's API, you can go ahead into the docs once again, look for this header here that mentions authorization, and then go through the OpenAI dashboard to grab your API key and create a new generic credential type here underneath this dropdown. I won't go through those steps here. Let me know if you'd like a dedicated video on that. Going forward to the next steps, this is where we're going to be doing things a little bit differently compared to some of the other HTTP requests and APIs we've integrated with in the past. Instead of sending JSON to this API, we're going to be making use of this form data body type. This is because we do want to pass in that reference image that we generated from before as the first frame into this, and we're going to be making use of that built-in n8n binary file to do so. And in order to do that, we have to use form data here. So let's go through these parameters one by one and see how we set this up. The first one that's required here from the docs is going to be the prompt we need. And so they have this example here, but we're going to be taking our prompt that we're splitting off and iterating in this loop here and grabbing the individual prompt we want to process. And so if I pull this up, we can see that we're using this iterate prompts node to grab the current item out of the loop we're processing over. And so we made 3 different prompts or 3 different video scripts for this UGC video. As we iterate over this loop, we're going to grab script 1, script 2, script 3 and process those individually. And so we can see we have the full details here, seconds 1 through 12 of our script 1 breakdown. As this loop continues through all these steps and goes back to iterate prompts, we're going to then move on to script 2 and script 3. So it's important to keep in mind that as we process over these items in this loop here, each of those items will be processed individually. The next step is going to be specifying what model we actually want to use. Right now for video generation, you can use either Sora 2 or Sora 2 Pro. If you remember from before, each of those are going to have different pricing and have their own strengths and weaknesses depending on the type of video you're trying to generate. So for right now, just to keep costs down, I'm just going to use the Sora 2 model. Going forward, we're going to then specify the seconds field for how long we want this video to be. Since in our script from before, we specified that we want a 12-second script, I'm going to add in 12 seconds here just to keep that matched up and avoid any clipping or cutting off of the video when we wouldn't expect it. The next parameter is going to be size. This is where we define the dimensions of the video we're trying to generate. And if you remember from before, we have to use the exact same dimensions we created from before for that first frame reference image that we want to get passed in. So this is going to be 720 by 1280, and that is going to match up to this image here where we define we want it to be 720 by 1280. If you don't have these matching, you are going to run into an error that says bad request. So very important those match together when you're building this. Going down further, this is going to be where we actually pass in that reference image using this n8n binary file type. So we're not using form data. We're going to switch this to n8n binary data, and then we're going to pass in the name as input reference. Going back to the docs, this is going to be what the OpenAI's API expects here. So -f, that just means that's the form input that OpenAI is expecting, named input reference. We have to match that right here. We then define what is the data input we want to match up against. Since our resize image had an output called data, we're just going to grab that, paste that in here, and that is going to pass off our resized image that has that exact same dimension match in order to go forward. So very important you follow those image steps here to avoid any errors working with the Sora 2 API. So that's going to run. We're going to come here to the right hand side, and we're going to see that we get back a couple of different result items here in the response. We don't quite have a video yet, and that's something that is important to note. Generating a video with Sora 2 takes some time. It's very compute heavy. There's a lot of processing to do, and so we're not going to get back a video we can download immediately. And so what we have to do is make use of this video ID we get back here and continuously check on the status of how OpenAI is processing this video. So I'm going to go forward into the next node where we have a brief delay of 15 seconds. Then we're going to make another HTTP request back into the video API where we're going to pass in that exact same ID to go ahead and get the details of how this video generation is progressing. So we can now see here, this was ran 15 times, but if I go to an earlier one, we can then see that the status was queued, and then we move on to in progress. And finally, at the end, it's going to be completed. And so we don't have the ability to actually download the video until it's completed. So we're going to be making use of this practice called polling, where we're going to look at the result of our request here. And so on an earlier one, this is going to be queued. We're going to check its status. We're going to see if that status from here on the left-hand side is equal to completed. If it's true, we're going to go forward with downloading that video. But if it's not completed, we're going to loop back here and wait another 15 seconds before we check again. And so this will continuously check here until we get that completed status set here before proceeding. This approach is called polling, and it's how you should work with these asynchronous APIs that have long-running jobs. So now we have our result set to completed. It's time to go ahead and download that video. And so we're going to make a final HTTP request here to this OpenAI/videos URL, but then we're going to add on this /content path at the very end of that request. So the ID is the same. We're asking for the content, and that's going to actually give us this MP4 as a response so we can download that video for later processing. So we can click download here to go ahead and start a download, or we can go ahead and view that final video. Moving on to the final step here, we're going to use the built-in Google Drive node where we upload our data file here from the left-hand side. So our exact same video we just downloaded from before. We're going to use the file resource, the upload operation, and take this data input here on the left-hand side as what we're passing off to this Google Drive node. So we're taking this video file, we're going to give it a name. It's called just UGC video. We're going to give it a number titled by number, run index +1. And so we can see for however many videos we're generating, we're going to title it video 1, video 2, video 3, or however many scripts that got passed in. And we can see here in our Google Drive folder, we're going to get those labeled accordingly. Going back, we're going to then specify our connected Google Drive account. So you need to go through the steps to set up your Google Drive credential. And finally, detail your parent folder where you want these files to get saved. And so I did the by URL option here. And then I just simply copied and pasted the folder URL of where I wanted these to get saved. And so drop that in, and we're all set here for our Google Drive upload. After that file gets uploaded, that is going to mark the end of this single iteration of the loop we've set up here. And so since we had 3 inputs here into our splitting out our prompts into iterating prompts, this is all going to repeat 3 separate times until we reach the end here of all of those prompts passed in until this automation finishes. So just something to be aware of. That's how loops work inside of n8n, where each of these are going to get processed one by one sequentially.
All right, before you go, make sure to hit the like and subscribe button. Seriously, do it, because we're going to be breaking down all of the AI automations that we use to run all of our businesses. They're super helpful, and we're going to break down exactly how we do them on this YouTube channel. So make sure to like and then subscribe, and then you'll get notified when we publish new workflows that can make your businesses run 20 times more efficiently, just like we're seeing here at the recap and the other businesses that we're running. The other item is join our school community for free. The link's in the description. You'll be able to get this template, this automation that we just ran through in this video, completely for free. You can go to school and navigate to the video that you want, and then you can download the JSON output for the n8n automation. With that, you can upload it into your n8n, clone it, and then tune it for your business and your use cases. So like and subscribe, join our free community to get this automation for yourself, and we'll see you in the next video.